16 of Neetcode 50, interleaving strings. So we're going to be giving 3 strings. And all right, so let's take a look at this example. To the left, we have a string entirely made up of red letters, and to the right, we have a string entirely made up of blue colors. So the red color string is going to be S1, and blue color string is going to be S2, and the string that is composed of both red and blue is going to be S3. We're asking if with the exact same letters that we have, can we actually make up S3 with S1 and S2? And also, interleaving means that the order in which the letter appears in both string have to be exactly the same in which they appear in string 3. So these examples are really, really bad because they don't really show the complexity of it. But let's take a look at this, which I like a lot. So example 3, we have A, B, C, and X, Y, Z. The output is false, Y. Okay, so we have A and B. Up to here, it's fine because we can see that they appear both in S1, right? That's another thing, right? If we added like a W here, well, a W does not appear in S1 or S2, so that will be false, right? But now we have A and B, which appears in that exact same order in S1, so it's fine. Then we have X and Z, but there's actually a Y that comes before the Z inside S2, so this is not working, right? What will have worked though, it's if we change the Z by the Y in this S2 string. So we're going to use dynamic programming to solve this problem. And I will show you basically how we do this on this board. So let's take that same example we had before. So we have ABC and we have XYZ. One thing we could potentially do is to basically just have 2 pointers. So we have 1 pointers here at A and 1 pointer here at X, and we just go see if that first letter is equal to that first letter of that string 3. Um, so this is an analogy we're going to keep for our dynamic programming solution, which is going to be more efficient than simply having these 2 pointers. Um, so to the left, you can see the final results of our dynamic programming solution. I just want to basically explain you from the end why it makes sense, and then we're going to actually do the formal path of this dynamic programming solution. So let's go here. Okay, we start with A and X, right? These are our 2 pointers, and we want to see is well, the first letter either X or A. If that fails from beginning, well, we know that this is not gonna work. Okay, so the answer to my previous question was yes, because we have A in that ABC. So now we can move our pointer here. All right, so we're gonna now point to the B in ABC, and we're also gonna do something quite similar inside our 2D grids. We're just gonna scratch this A. We're gonna put a through in this case, and we're gonna go 1 down. So now we did our A, so we're just gonna go see B, and we're never ever gonna touch again this row. And now what is the second question is basically is the index 1 here. And by the way, the index 1 is basically or the index in S3, which is this string here, it's basically going to be equal to that index here. So now we're at index 0, this is index 1, right? So if we move again to the right, we're going to have basically index 2 again. So if we do this and we have index 2 and index 0, we're going to be at index 2 of of this S3. But now we're not there yet. So we're just going to ask if basically this X or this P is the next value inside our S3. It appears that this X value is actually the next value. So we're just going to scratch it. We're going to pass to the next value. So we're going to move our pointer to the right. And also what we're going to do is that we're going to scratch this value inside our grid, and we're just going to go to the Y. And by doing so, we're just never going to touch this column again. So we're going to put it through here at this case, and we're going to move to the right. And right now you can see that we have basically a clean path of truths. This is because initially they are all set to false. But just for this example, I'm giving you like the solution right away. And I want to explain the solution, why it makes sense, because it is not always obvious. And sometimes you understand why it works, but it still doesn't make sense at all. So I just want to explain this logic so you can see it clearly, and then I will basically go through the actual example of doing our bottom-up solution in DP. Right, so now the next thing that we're going to be checking is B or Y the next value? Well, B is the next value. So we're gonna scratch B. We're gonna go one down. We're gonna put it through here in this case, and we're gonna just scratch this entire row. Now we're gonna move our pointer again, and we're gonna have a C, which is the next letter. Oh, by the way, in my previous example, I scratched a Y, but we didn't use it yet, so there's no way to scratch it. But still, you can set the next letter. So the next three of the S3 string is a C. So we're just going to scratch a C, and we're going to go one row down, and we're going to scratch this row after putting it through exactly where that true value is. Now notice that we are sort of entering a out of bound era with the ABC string, right? We did all the characters. So now basically we are just going to go take a look at the XYZ string to see if they match the rest of the characters in our S3 strings. And we should technically get to that last index. If we don't, it must mean that we don't have a correct answer. But in our case, well, you can set here the Y is the next value that appears in S3. So we're just going to scratch this Y everywhere. We're going to basically put a true inside this cell 3-1, and we're going to scratch this entire column. And now we're going to scratch the Z, which is the last letter of both strings. We're going to scratch this, we're going to put a true, and we're going to reach this last cell, which is a true. All right, so this is the logic. Now let's actually go to the example from a bottom-up perspective. So let me click on undo a couple of times. All right, so first thing is that initially we're going to set a grid with a lot of falses. So all these truths are basically something we're going to get along the way. But initially, we're going to have false pretty much everywhere, except in the last corner, like the bottom right corner. Because the bottom right corner is referring to the index 3 of each string, which is actually nothing, right? It's like an out of bound indexes. And if we add the two indexes, 3 and 3, we're going to have 6. So if we take that 6 and go see what is at the index 6 of the string 3, we'll also have something that is out of bound and does not exist. So this is like the same thing of saying if adding is adding basically an empty string plus an empty string this the same as or equal to an empty string? Yes. So this is why we have it true. And what we're going to do then is that we're going to go in a backward way. So we'll start from the last row, from the last column, and we're just going to go to the left. And what we're going to do is that we're going to check if by taking that indexes here of the row index plus the column index. Right now we're at 5. So is basically the string or the character at the index 5 of the S3 strings the same as either the value here, which is an empty string. Is it an empty string or is it Z? Here it is actually Z. So what we're going to do, since it is Z, and we have basically a match in the horizontal of the horizontal word, right? Because ABC is what I refer to as the vertical words, and XYZ is what I refer to as the horizontal word. So I'm just gonna check one value to the right, and if it is a true, I'm gonna set a true here as well. And I'm gonna keep moving. I'm gonna go here, and now I will add both indexes, so 3 and 1. And basically this is giving me 4. So within this S3 up here at the index 4, what is the character? It's a Y, right? So it's basically the Y that we have in our string equal to the character here on the column, which is a Y. So yes. Or is it also equal to another empty character, which is well, it's an empty string, right? No, but it is equal to the column's value. So it is equal to the Y. So I'm just gonna take a look at the right cases, and if the right cell is a true again, I'm gonna put true. And now on the on this last cell, so now on this right on this left cell, pardon me, we're gonna take a look at the index to the of the row and the index of the column. The index of the row is 3 and the index of the column is 0. So by hiding them, we have index 3. So if we take a look at what is the character inside our string tree at the index 3, we're going to see that this character is actually a C. So we're going to ask is basically see the value in this in this um, vertical word, or this horizontal word, a C. It is not, right? Because we have an empty string in the vertical word, and we have an X in the horizontal word. So what we're going to do is that we're just going to go one row up, and we're going to keep our search going, and we're going to add the two indexes. So we have in our row an index 2, and in our column we have the index 3, which is a 5. But at the index 5 inside our string tree, we have a Z. So it is not matching either the C or the empty string that we have along our column. So we're going to go one cell to the left, and we're going to take again these two indexes. I think I don't need to repeat myself. Just going to be at index 4, and at index 4 inside or string tree, we have a Y, and the Y is not matching the C along the row, and it is not matching the Z along the column. So we're going to go one cell to the left, and we are going to have index 3, right? 2 plus 1. And inside our string tree at the index 3, we have a C, and C is actually matching it's actually matching the value of the column. And this is of the row, pardon me. So if it is matching the value of the word inside the row or the vertical word, we're just going to take a look at one cell down. If it was matching the value of the word that is horizontal, so X, Y, and Z, we will have look at the left, at the right values, pardon me. So since it is matching the value of the vertical word, we're going to take a look at the cell that is one row down, this particular cell. And we are going to put it through in that particular row, at that particular column, only if the value of the cell one row down is true. In our case, it is true, so we're going to put a T here. And we're going to keep going. We're going to go see here at the row 2, column index 0. We're gonna basically no matching items. We're gonna basically do the same thing until we reach this position here. So we're gonna be at the index 1 plus 1 and the index 2. Inside index 2 of our string tree, we have a character B, which is matching the vertical word. So what we will do if it is matching the vertical word, well, we are gonna basically take a look at the cell that is one row down, and if it is a true, and only if, we are gonna put a true here in this cell as well. Okay, so notice also that once we stretch these values, we're never gonna go in these cells again. So right now, we basically to complete the word, and now I'll need to scratch this again. Actually, no, not yet. We're gonna scratch though these columns, but notice that now since we added our B, what is left for us to do? We can either add a and a X, or we can add a X and a. So let's go ahead and see what is left for us to do. So we're gonna go one cell to the left, and we're going to be at the index 1, and at the index 1 we have X. So now we're going to have a matching character with the horizontal word. So we're just going to take a look at the cell that is the one to the right, and if it is a true, and only if, we're going to put it true at this position inside the grid. So now we're going to put it true, and then from here we are just never going to touch this particular column again. So now the only way that this thing works is if basically we add a, and this is going to work because at the index 0 we're going to have a 0 inside of S3. So we have a matching character along the row. So we're going to take a look at what is the value one row down, and it is going to be a true. So since we're seeing a true, we are allowed to put a true in that top left cell. And this is exactly what we are going to return. We're going to return the value of the top left cell, and this is going to be true if there is a clear path up to the end of the words in the correct order, right? So we're going to have our basically our answer to the solution. If it is false, it means that there is no path, or there's basically there are missing characters, or there is an order that we are not respecting. So let's go ahead and solve the problem. First thing that we want to do is basically to check if the len of the string 1 and the len of the string 2 together are adds up to the len of the string 3, because otherwise it means that we added or removed a character in any of these two strings. So in this case, that will just not work. So if the len of S1 plus the len of S2 is not equal to the len of S3, if this is true, we're going to be willing to return false, because we know that this is not going to work right away. So there's no need to keep going in that directions. And now we're going to create our grid. So I will call this DB for dynamic programming. And what I want is basically initially to have a couple of falses pretty much everywhere. And I won't have falses for the len of the S2, because the second word was what you refer to as the horizontal word, or the len of the of a single row. So I'm gonna do this row's length times basically the len of S2, and I'm also adding an extra an extra column, right? And I want to have this basically for the len of for the len of S1, because S1 was the vertical word or the number of rows, and we are also adding an additional row at the end. Great. So then we also want to have that basically that bottom right corner to be equal to true, because we know that by adding an out of bound character in both strings, we're going to have also an out of bound characters in our string 3. So the DP at the len of S1, which is basically the last row, and at the len of S2, which is the last column inside the row, is going to be set to true. And now we're going to have basically two for loops, because we are going to go for every single values inside our grid, and we're going to start that from the bottom because we're using a bottom-up approach. So I'm going to add initially for I in the range of basically the last row up to the top row. So I'm going to do this by saying that I initially want to start at S1, and I want to go up to the index 0. So I will set a bounding index to be the index -1, and I am going to put a -1 as a true value to specify that I want this in a reverse order. And I will do this basically the same thing for the columns inside each row. So I want to add basically the last column, which is going to be referred to the index of the len of S2, and I want to go up to the index 0. So my bounding index is -1, and I want to do this in a reverse order. So I'm going to add a -1 at the end. And what I want to do, I want to have to check basically. First, I'm going to check the if the cell that I'm at basically is this is this matching the character of the horizontal word or the vertical word. But first of all, I just want to check if I am in bound, because if I'm, let's say, at the top or at the far right column, I know that I can't go to the right. Like in our example, if I'm at, it's getting quite messy, but if I'm at this really cells, I know that we are referring right now to basically the index out of bound of our horizontal words. So there's no value to check to the right. Hence, we are sure that we know that this is actually we don't want to take a look at the character to the right, and we are just going to take a look here if I is smaller than the len of S1, because otherwise it means that we are going to go out of bound by taking a look at the value to the right, because we're going to take a look at what is the next value, or what is the value to the cell to the right. But if this value is not something that exists, we're going to get an out of bound error. So this is why we have this here. So we just want to see if we are not at this particular position. Otherwise, all the other positions shall be just fine for us. But if this test passes, we want to take a look at the character at the index I inside S1, and is this character actually matching the character in S3 at the index I plus G, right? This is exactly what we are doing. We're just taking a look at the character at the index I inside inside the vertical word, And we're taking a look also at the index of the string tree, which is the word that is supposed to be composed of S1 and S2. And we're taking a look at if basically by adding the index of the row and the index of the column, taking that index and searching inside S3, is that character the same as the character along the vertical word or the horizontal word? So we're gonna basically have pretty much the same if statement after this. Um, and lastly, if this matches, it means that we have a match along the vertical word. And what were we doing when we had a match along the vertical word? We're gonna basically take a look at the case that it was one row down to this particular case. So we're just gonna say dp at the index I plus 1 and add the row g. So, right, so this is going to be the cell that is right under here. And this, if this value is true, this center if statement is going to be triggered as true. So we can set that particular grid's position at the index ig to be equal to true. I'm going to have something super similar after this, but I just want to do this for the column. So if the g is smaller than the length of S2. So if we're not like on the far right column, meaning that there is no value to the right to check at, well, we can then check if the value of the S2 at the index of G is equal to the index S3 at the index I plus G. All right, so now we're gonna see if we have a matching character. If we have a matching character inside a place that is inbound, we're going to take a look at the cell that is to the right. So if the dp at the same row but at a column that is one to the right, is if this is equal to true, well then we want to set that particular position to be and now I messed up these. All right, so we want to set these to be equal to true, and this way we're going to go up to the top left corner, and the top left corner is going to tell us whether or not we have a clear path. And the clear path means that we actually can create that S3 words using interleaving the interleaving strings. So we're going to return basically the row 0 and the column 0. And let's test this out. And that works. Awesome. So in terms of space and time complexity, well, for time complexity, we are going through every single character inside each words. So if basically each words are of the length n, we're gonna have n squared, a big O of n squared time complexity. If they're not the same, and we say that one word is n and the other word is of length m, we're gonna have a big O of n times m for the time complexity. And for the space complexity, it's going to be exactly the same as the time complexity because we are creating a grid that is exactly the length of the two strings multiplied with one another. So with that being said, I hope you enjoyed the video. I hope you learned, and I hope to see you in the next one.